Equilibrium calculations using ICE method. Equilibrium constants and concentrations can often be deduced by carefully examining data about the initial and equilibrium concentrations. ICE. I stands for initial concentration, C for change in concentration, and E is for the concentration at equilibrium. We must always remember all of this. First, the initial concentration of all species product will be 0. Second is the change in concentration from initial to equilibrium and is expressed with negative or positive with a variable x equating to the coefficient of the balance equation. And lastly, the concentration at equilibrium is the summation of the initial and the change in concentration. This concentration at equilibrium is used to calculate equilibrium constant. Now let's directly solve this problem. The initial concentration of the hydrogen and the chlorine in a flask were 0.56 mol per liter. The equilibrium concentration of the hydrogen chloride was found to be 0.356 mol per liter. Let's now calculate the equilibrium concentration of the reactants using the ICE table. The ICE table goes like this. At the problem, it has been stated that the initial concentration of the hydrogen and chlorine is both 0.56 mol per liter. So we put here at the initial the 0.56, but it hasn't been stated that the initial of hydrogen chloride. So we presume that it is equals to 0. But it has been stated that the concentration at equilibrium of hydrogen chloride will be 0.356. That's why we put the value of 0.356 at third row, third column. Now, you're going to observe that the change in concentration of hydrogen and chlorine are both in negative x, and the hydrogen chloride are in positive 2x. If you are going back to the things that I've been stated to take note, you'll observe that the change in concentration is expressed in negative or positive with the variable x. Now, how do I get the change in concentration of the hydrogen and chlorine? I use the ratio and proportion. The 1 hydrogen is equals to 2 hydrogen chloride. The value of hydrogen is x and the hydrogen chloride will be 0.356. Now I use to cross multiply 0.356 to 1 and x to 2 of the hydrogen chloride. That's why I get 2x is equals to 0.356. In order to get the x, I've used to divide both sides by 2. That's why I get 0.178. The same thing with the chlorine, since the value of initial concentration of the chlorine is the same with the hydrogen. That's why I use the same process, and I also get the 0.178. Now let's do the substitution. I substitute the value of x to 0.178 and use negative sign for both hydrogen and chlorine. But in hydrogen chloride, change in concentration, I used to multiply the value of x, which is 0.178 to 2. That's why I get 0.356. Since the initial concentration of hydrogen chloride is 0 and its concentration at equilibrium will be 0.356, it is clear that the change in concentration will also be 0.356. Now, to get the equilibrium or the concentration at equilibrium, we are going back again to the things that we've been said before, that the concentration at equilibrium will be the summation of the initial concentration and the change in concentration. In hydrogen, we are going to add the 0.560 to negative 0.178. That's why we get the 0.382. The same thing with the chlorine, 0.56 added to negative 0.178, we get the value of 0.382 as the concentration at equilibrium. And since the value of the initial concentration of hydrogen chloride will be 0, when we are going to add it to the change in concentration of 0.356, we still have the concentration at equilibrium equal to 0.356. So, the concentration at equilibrium of hydrogen and chlorine will be 0.382 and the hydrogen chloride will be 0.356 now.